find q prime first. So we have this quotient, a rational function. So write down the quotient rule to begin this, okay? How do you find a derivative of a fraction function? We take g squared in the bottom. We put g squared in the bottom. And on top, we do g times f prime minus f times g prime, okay? So let me label the pieces here, like f prime and g prime. So f is the original numerator of the function. So f will be just x. Take the derivative of that. What is f prime? F prime will be just 1. Now let's do g. G is the bottom of the fraction, which is x squared plus 49. And if you take the derivative of that, that's going to give you 2x. You know, you can put these in parentheses because you'll be multiplying these pieces together. You don't have to, but you know, I'll do that this time. So I got all of these written down, ready to go. So let's find q prime of x. Let's find that derivative function. So I'll try to make this long fraction bar, but in the bottom of the fraction, let's see what the formula is telling us to do. They're saying do g squared. So where's g? Aha, g is right there. G is this orange highlighted binomial. So do x squared plus 49 squared. All right, let's go to the top of the fraction. The first thing that I see on top of the fraction is g. So put that there, and that is that orange highlighted x squared plus 49. All right, let me go to the next one. What are we multiplying this by? We're multiplying this orange by this f prime. What is f prime? Oh, look at that, it's just 1. So I was going to put 1 next to it, but you know, if you multiply something by 1, it's the same, right? So I don't have to put the times 1 there. I'll do the minus sign because of the quotient rule says subtract after that. Now what comes next? I need to put f next. F is x. So let me put x there. And we're multiplying x by what? G prime. Find G prime. Oh, G prime right there. So I'm multiplying that by 2x. All right, let me simplify this a little bit. The numerator, okay? The denominator, I'm just going to copy it down exactly the same. I'll get x squared plus 49 out of the parenthesis. But if I multiply x times 2x, that's going to give me 2x squared. And I have like terms now. I can do 1x squared minus 2x squared, and that's going to give me negative x squared. So I'll write it as 49 minus x squared for the numerator. And in the bottom, I will put x squared plus 49 squared. That's fine. That is what q prime is, and I can stop here. Okay, this is a fine looking answer. Let me see if I can draw a square over here. That is the answer. Or if you want to factor the numerator, I guess someone can write it as what? You can write it as 7 minus x times 7 plus x all over x squared plus 49 squared. But what I boxed here, that's fine. So I'll stop there. All right, next, what do they want us to do with this? Okay, they said part B, find the equation of a tangent line at the origin. Now, origin, the x-coordinate and the y-coordinates are both 0, right? So what they are saying is x of 1 is 1, 0, I'm not saying 1 for. Y of 1 is also 0 because it's origin. But what's the slope? What is the slope? Well, we don't know, but we can find it, right? We have the slope cooker right here. That's what is going to give us the slope. So find the slope by plugging in the given x value into the derivative function. That's how you find slope of a tangent line. So let's do that. If I plug in 0 into this function, I have to plug in 0 here and 0 there. That's going to be 49 minus 0 squared over 0 squared plus 49 squared. Oh, it's going to be yucky. That is going to be 49 on top, right? Focus with me. Focus here. So 49 minus 0, that's just 49, right? Now look at this. Inside the parenthesis, you're going to get 49, right? That's orange is going to come out as 49. But when they tell you to square it, I don't want to get a calculator. I don't have one right now. So instead of writing 49 squared, how about I write it as 49 times 49? Because that's what squaring is, right? And you know what I can do here is I can cross out one of the 49 in the bottom and say that the final answer is 1 over 49. It simplifies to 1 over 49. So guess what? That is the slope. So write that down as the slope, and we are ready to do the point slope form. Okay, let me move this over here so that I can look at it while I write the answer. So these are my 3 ingredients to the point slope form. And point slope form goes like this. Y minus y1 equals m times x minus x1. So let's plug in everything. I'll get y minus 0 equals 1 over 49 times x minus 0. Because both the x and the y's of 1 values are 0. Now, that's kind of ugly. Let us simplify this. I can write that as y equals 1 over 49 x. Okay? And that is the equation of the tangent line at the origin. Let's do another one. They gave us a point value where x of 1 is negative 1 and y of 1 is negative 1 over 50. Now, the only thing that we are missing is the slope value. What is m? Well, in order to find it, we have to use the derivative function. Okay? So this thing that that we came up with, let me copy this down. I'll copy this down because that is what's going to give us the slope of a tangent line. So this time, what do you have to plug in to the x value? You have to plug in x of negative 1. So let's see what happens. So I will get 49 minus negative 1 squared, right? And in the bottom of the fraction, I'll get negative 1 squared plus 49 squared. All right, let's simplify this. 49 plus 1, right? 49, no, I'm wrong. 49 minus 1. Because if you square this first, that's going to give you 1. The bottom of the fraction will be what? 1 plus 49 squared. It's not going to simplify nicely, huh? So the numerator is 48. The denominator is going to be 50 squared, which is going to be 2500. Can we simplify this to reduce this fraction? I guess we can. I think we can reduce this by 4, don't we? So if I divide, you know what, let me get a calculator and just get the, reduced fraction real quick for you. 48 divided by 2500. That simplifies to 12 over 625. So that is the slope of this tangent line. So write down 12 over 625 as the slope. And we're ready to do the point slope form using these 3 numbers. Y minus y1 equals m times x minus x1. The left side of the equal sign will get y minus negative 1 over 50. So that's going to turn into y plus 1 over 50. equals, m is 12 over 625. But inside this parenthesis, I have to do x minus x1. But x1 is -1, so subtracting a negative, that double negative will turn into +1 again. And I will stop there. I don't think we need to distribute and subtract 1 over 50 to put it in a slope-intercept form. They just said equation of a tangent line. That's an equation, all right. So I'm not going to change that into a slope-intercept form. All right, let's do the last one. They want us to estimate points at which the tangent line Q is horizontal. Anytime you see this, tangent line, horizontal, they're talking about a line whose slope is 0. So set the derivative equal to 0. That's what you're going to do. Set Q of x equal to 0, and you will solve for the x values that will make this true. So let's go grab that derivative that we found up here, this answer that I put in the box. All right, so let me copy this over here. All right, I'm going to set this equal to what? 0. Well, remember, fraction is 0 when the top of the fraction is 0, right? Or, if you want to cancel out the denominator, you can think about multiplying both sides by the denominator of x squared plus 49 squared. You can multiply the right side by x squared plus 49 squared. What will happen? This cancels out. Also, 0 times anything is just 0, right? So only thing left is the numerator equals 0. So anytime you see a fraction equal to 0, that means the top of the fraction is 0, okay? I'm going to write that green parts as a new equation over here, okay? So 49, oopsie, let me use a black pen. I don't want to use a gray pen. 49 minus x squared equals 0. Let's solve this. I can factor the left side as 7 minus x and 7 plus x. Now, if I set each of these equal to 0, I'll get 7 minus x equals 0. And this one right there will give me 7 plus x equals 0. All right, let's get the answer from this side. Over here, if I simply move this x to the right side, 7 equals positive x. So the first answer is x equals 7. If I subtract 7 from both sides on this equation, on the orange side, I will get x equals -7. So two answers. X can be either positive 7 or -7. That's when the slope of this tangent line is 0. Therefore, the slope of the tangent line will be horizontal. But they said write an ordered pair, right? So I know the x value is 7 and x value is -7. But I don't know their y values yet. How do we find y values when we have x values? We plug it back into the original function. So let me go up and grab that original function. I haven't worked with this guy in a long time, but let me copy this down here. Because if I want the y, I need to plug it into the original function, not the derivative. Because you plug it into the derivative function if you want the slope, but if you simply want the y value, plug it into the original function. So if I plug in 7 here, I'll get 7 over 7 squared plus 49. I want to do this without a calculator. So let me see if I can try to simplify this. So what's that going to be? That is 7 over 49 plus 49, isn't it? I can write this as 7 over 2 times 49, isn't it? Because if you add 49 and 49 together, that's the same as multiplying 49 by 2. I can write this as 7 over 2 times 7 times 7, isn't it? Because that's what 49 is. And look what I'm about to do. I'm going to cross out the 7 on top and one of the 7 in the bottom. So if I simplify the answer, the first y value comes out to be 1 over 2 times 7, 14. So here is the y value for x of 7. Let me do the same type of thing, but this time I'm about to plug in negative 7. So if I plug in negative 7 here and there, let's see what happens. Negative 7 over negative 7 squared plus 49, which is negative 7 over 49 plus 49. Hey, it's the same thing, isn't it? I can write that as negative 7 over 2 times 49, right? Because adding 249 is the same as multiplying 49 by 2. See, multiplication is repeated addition. So negative 7 over 2 times 7 times 7, right? So I can cross out this 7 on top, one of the 7 in the bottom, and write the answer as negative 1 over 14. So when you plug in negative 7, and you know what, you could have done this just on the scientific calculator, and I don't mind at all, but I didn't want to change to the different browser to open up a Desmos. And you know, this one was nice. We were able to do this without a calculator. But that's it. We went over this one big problem when we started with finding the derivative using the quotient rule, found some equation of tangent line using that derivative function. And the last one was special. We were trying to find points, okay, whose tangent line to this function is horizontal. And the trick was to set the derivative equal to 0, okay?